Hey everybody, Mr. Morel here, and we're going to talk about homework assignment 8.1, which is about discrete and continuous. Now this unit is going to be kind of a weird unit. It's like going to be a bridge between the stuff we just did. Well, every unit is a bridge between the stuff we just did and the stuff we're going to do. But this is going to be kind of a short unit where we start looking at these weird curved graphs that we started seeing last unit. So if you remember last unit, with the geometric sequences, we started to see the graphs were like curving, and now we want to explore those more. So this first homework assignment is kind of just going to be a good vocabulary assignment. We need to learn a couple of words before we can learn more about those curved units, or the curved graphs. And so let's go ahead and just get these vocabulary words out of the way. Number one, a linear function. And we have this word bank down here to help us out. A linear function is, let's see, we're going to call it a function. Oh my gosh. Pretend like you can read that. Okay, a linear function is a function where, when graphed, the information forms a line. That's going to just be our basic definition. So it's a linear function, or a function where when graphed, the information forms a line. Now, let's talk about an exponential function. An exponential function is a function where the information, we're going to say, grows or decays exponentially. Now, you have seen geometric sequences. Geometric sequences are a type of exponential function. So that shouldn't be too weird. It's just like things that are going to grow or shrink exponentially. Okay. Discrete is a set. Okay, so a set of data is said to be discrete if the data belonging to the set are distinct and separate. And one way to remember that discrete data is discrete is that it's usually data that you're going to count. Okay, continuous data is a set of data where the values belonging to the set can take any value within a given interval. Usually, continuous data is measured. Alright, I forgot to keep marking off these words. I think we got all of these words marked off. Okay, let's go down here, and this homework assignment, of course, is called Discrete or Continuous. Is going to focus on these two vocabulary words down here. So let me go ahead and slide the page up, and we're just going to decide if these situations are discrete or continuous, or if we don't have enough information to be able to tell. So, first of all, we're going to look at the graph. The way that you can tell if a graph is discrete or continuous is by looking to see if the dots are connected or not connected. The way that the dots are now, because it's just a couple of dots that are not connected, we're going to call that a discrete graph. If the dots were connected, then we would call it continuous. So for example, in question 7, the reason why question 7 is continuous is because you have a continuous line. You can see that the line is all connected right here. So whatever the data was that was collected, it was happening continuously. Where the data in question 5 that was collected was like sporadic. It was dotted. Whatever. Okay. Let me see. So I'm going to have you do questions 8 and 10 alone. But what you want to ask yourself is the thing you're looking at, is it something that you're counting, or is it something that you're measuring? If it's something that you're counting, it's going to be discrete. If it's something that you're measuring, then it's going to be continuous. Let's look at this equation. So the equation here, we have f of x equals 3x plus 2. And we want to know if that's discrete, continuous, or not enough information. Well, as it turns out, I mean, there's a lot of different ways to represent information and functions, like we talked about tables and graphs and equations and stories and all these things. We've done that all year. And there's different reasons why you would use different information and different representations. The thing is that a table and a graph, tables and equations are great because they're super helpful to see a lot of different things. But one thing that a table and a graph doesn't help, a table and an equation don't help us do is figure out if the situation is discrete or continuous. So when I look at this equation, I don't know if the information that's being gathered or plugged in, I don't know if that's happening continuously or discretely. There's just not enough information to be able to tell. So let's go on to the next page. Okay, so we've got a situation here. The number of laps you run each day during the week. Well, kind of like we said before, we would be counting a number of laps. And so the data that we're collecting is actually discrete data, because you would just look back at your week and count how many you've done. So that's discrete. Where the situation over here, question 13, says the distance you've run during a track meet. Well, if you've run a certain amount of distance and you're going to measure that distance, that's going to be continuous because the information could take any value within a set interval. You could run a foot or a half a foot or a couple inches, like whatever. The information you're collecting is continuous. It could take any value within there. All right, let's go ahead and continue to level 3. So level 3 gives us kind of a big story. I want to help you get started with the story, but I won't answer all of the questions. I'm planning, let's see. So the story says, okay, sorry, I'm crazy. The question asks us to create a graph that most accurately represents the story. So we really have to think about what the story is telling us and how we're supposed to graph it. So in the story it says that you have been filling up the pool for the last 3 hours. Your swimming pool holds 1,500 gallons, and you figured out that in 3 hours you can add 500 gallons of water. So we have been filling up the pool for 3 hours already. So what I want you to think about are these questions right here. These questions, you're not required to answer them to make this graph, but I would highly recommend that you answer them before you make the graph. So for example, this first guided question here, how many gallons are there in the pool now? And it's telling us that right now, x equals 0. So right now, in the story, let's see, we have been filling up for 3 hours, and we know that every 3 hours we can add 500 gallons. So right now, we know that there are 500 gallons in the pool. And so what we know about the pool is that we have, right now, 500 gallons. So we know that this dot is going to end up on our graph somewhere. So then you're going to want to ask yourself, okay, what's the highest point on the graph? What's going to be the lowest point on the graph? In other words, remember that this axis right here is time. This is gallons. So it's kind of asking you, how high is your graph going to go? How low is it going to go? What's the most amount of what's the most amount of water that the pool can hold? What's the least amount? It wants to understand the interval of time covered within the story. When did we start filling the pool? When will we finish filling the pool? And things like that. So that's my hint for level 3. And of course, like always on level 4, you're kind of on your own to read the story, to dissect it, and to think about the things that it's telling you. All right, good luck. I will see you guys later. Okay, bye.